Hi everyone, this is Andrea Vischioni from Heidelberg Instruments Nano, and I've been here in Unicamp for the last week to perform the upgrade to the NanoFrazor tool. We upgraded the tool adding the DLS module, the direct laser sublimation module, that will help the research here, integrating the laser together with the TSPL. So just a brief introduction about the NanoFrazor. The NanoFrazor is a nanolithography tool specialized in thermal scanning probe lithography, or TSPL, and it takes advantage of a silicon heated tip that is removing material, is sublimating material directly. So we pattern directly with the tip on a special resist that is called polyphthalide, or PPA. That is a special resist, and combined with the heated tip, we managed to write nanostructure. The installation that has been performed here was meant to upgrade the tool with the laser module, and so you can write with the NanoFrazor Explorer now in a mix and match condition. So you can write the high resolution part and the nanometric level on the most sensitive part of your sample with the tip, while you can then integrate everything with the laser module. So the laser is a 405 nanometers wavelength laser that is mounted on the Explorer. Take a look at how the system works. So I already imported some stuff for you. So here you can see the world map. So the world map is the part of the tool where we have all the coordinates and where we can place the pattern that we want to do, both with the laser and with the SPL. So we have the coordinate system here, and this is the optical microscope from the tool. So let's start first with the TSPL part. So we want to pattern the CCSNano logo. So I imported the logo, I place it wherever I want. So I want to place it here, let's say close to the tip. And once you set all the parameters, we can start the pattern. So you just have to move to the next session. I already did some pattern before, but yeah, let's try it again. So let's see it live. So now the tip is approaching, is performing all the calibration steps. So we know which temperature we are applying and which is the trajectory that the tip needs to do. And soon the pattern will start. Okay, now the pattern is starting. What's really interesting about the NanoFrazor that stands out versus the other tool is the closed loop lithography. So the closed loop lithography, what does it mean? Is a technique that allows the tool to write in one direction, while in the other direction with the whole tip we are reading the surface, and this helps the software to find the good set of parameters, because if we are patterning too shallow or too deep, the feedback will adjust accordingly. As you see now, is finding the good patterning parameters to write the field. So let's see if the feedback will adjust. We can increase the temperature to help the feedback a bit. Okay, so now the feedback is a bit converging. This is like the first test pattern, so we can just move and do another pattern, because with the NanoFrazor is a way of pattern. At first you need to do some test pattern, and then you can perform the actual pattern. So I moved in a cleaner area and I repeat the pattern. After this, I'm going to show you the laser part. So I already imported some design with the laser. They are bigger. The laser is way faster respect the TSPL, and it's like 100 times faster. So for a bigger structure that you need to pattern, the laser is a very good solution. Okay, the pattern time for this area that is around like 8 micron times 24 microns is around 1.5 minutes. So let's leave the tool operating. You can see the patterning in real time from the microscope. So you can see, I mean, it's really small, so you cannot really see what's going on, but you can see that we are removing material from on the tip. And here is the real reading, so we can just select and see how deep we are patching. So in this sample in particular is a BLO sample. It's one of the standard sample that we use in one of the standard processes, and is a sample that's built with 2 layers, one underlayer that is the PMMA and one layer of PPA. So the goal of the NanoFrazor is pattern deep enough, so more than the target depth that we have here, that is the thickness of the PPA, to be sure to open the mask, and the sample then will undergo to some wet development, this anisotropic wet etch, and after the wet etch is done, just with a solution of IPA and water or ethanol, for example, you can deposit metal and make your contact over your 2D material. Something that I didn't mention before is the maskless behavior of the NanoFrazor, because different from other lithography tool, the NanoFrazor does not need any marker, because you can read what you want to contact, for example, and you don't need any marker. So you can just look at the optical camera, go in the area of interest, do a reading, and then perform the TSPL or the laser contact. So the pattern now is nice, it's very good. We can select another layout. So I imported before some nice logo, so we can start with the inked Namitech logo first. So we can place close to the CCSNano, and here is going to be split in few different field. But if we would have to pattern an area like this with SPL, it will take much longer. So with the laser is around 3 minutes. So let's start with the laser. You can go in the laser tab, and you can see I already patterned something before, but let's zoom in so we can see in real time the patterning. Differently from the TSPL, the laser does not have a closed loop lithography, so we just remove the material. So we are sublimating the material with the high dose of the laser, and but we don't have a control over the depth as we have in TSPL. You can control, of course, the power and everything. So we have a lot of tests that you can perform prior to do the pattern, but that's really dependent on the application that you have to do. So you see now we are half of the pattern, and as you can see, we already patterned a way bigger area respect to the TSPL before, and is way faster. So during the configuration of the laser, we just find which is the position respect to the tip. So this like circle here is the exact laser spot position with reference to the tip position. So here is the tip. I didn't show you before, but this the NanoFrazor tip is the silicon tip. So it's made of 3 channels: the writer channel, the reader channel, and the common channel. And yeah, we take advantage of voltage applied to bend the cantilever and to heat it up.
Sou a Silvia, sou pesquisadora aqui do CCSNano, trabalho na linha de nanofabricação e materiais compósitos nanoestruturados. Essa semana nós tivemos uma visita de um técnico da Suíça para fazer um upgrade de um equipamento de litografia de ponta térmica que nós temos aqui no CCS, né? Ele é o único equipamento na América Latina. E a gente atualmente trabalha só com as estruturas nanométricas, com a ponta térmica. Esse upgrade é para a instalação do módulo laser, para fazer microestruturas, e a gente vai poder então integrar essas nanoestruturas com as microestruturas.
Meu nome é Paloma, eu sou pós-doc aqui no CCS. Eu trabalho na área de materiais e nanofabricação. Atualmente eu sou a principal pesquisadora trabalhando com o NanoFrazor. E nessa semana nós tivemos a instalação do módulo laser. Então, essa instalação vai melhorar muito as nossas capacidades, a gente vai conseguir atender novas demandas de fabricação. A gente tem demandas tanto nacionais quanto internacionais, fabricando principalmente estruturas fotônicas. Então, metasuperfícies, nanoantenas e agora partículas de ânos também.
Essa linha de pesquisa, né, ela está integrada à área 6 do Namitech. Né? Várias pesquisas estão sendo desenvolvidas com esse equipamento. Né? A atual, a mais nova que a gente está iniciando é o desenvolvimento de nanopartículas de ânos, né, que é algo inédito, né, o desenvolvimento dessas partículas com essa tecnologia de litografia de ponta térmica.
O trabalho que nós estamos fazendo aqui no CCS já começou antes da atualização, onde a gente já expandiu a capacidade, a compatibilidade de materiais dessa litografia para substratos dielétricos e também substratos flexíveis. Com essa atualização agora, a gente vai conseguir fazer novas estruturas fotônicas que foram modeladas por inteligência artificial com a técnica de inverse design. E além disso, essa atualização também traz o módulo Grayscale, que significa que a gente pode fazer perfis diferentes de profundidade, ou seja, que eles chamam de estrutura 2.5D. Isso pode ser um grande avanço para estruturas fotônicas, para aplicações de filtros de cor e até integração em óculos de realidade aumentada.